Here's the thing. This new image from Thailand should not look like this. When you run a comet through a Larson Sekanina rotational gradient, you expect symmetry, noise, maybe a faint tail. What you're seeing here is neither subtle nor symmetric. A bright, structured feature is pointing straight toward the sun, not drifting, not fading, not breaking apart. It's holding its shape, and it's doing it frame after frame. Look closely at the center. The inner coma isn't a smooth glow, it's stretched. Something inside 3I Atlas is pushing material sunward in a way that comets simply don't. Even after 2 weeks of observing, the orientation hasn't flipped, and the structure hasn't collapsed. If this were just processing artifacts, the direction would scramble. If it were dust, it wouldn't stay this coherent. And if it were solar pressure, it would point away from the sun, not into it. So right from the first image of the night, the message is pretty clear. Whatever 3I Atlas is doing, it's doing it again. And it's getting harder to explain with normal comet physics. Now let's put the December 7th and December 9th images side by side. When you look at them together, the pattern becomes impossible to ignore. On the left, the December 7th frame shows a small, tight sunward feature. It's there, but it's faint, almost hesitant. The jet barely extends past the nucleus, and the secondary structure on the opposite side is just a whisper. If you didn't know what you were looking at, you could mistake it for noise. But the right-hand image, taken only 48 hours later, wipes out that uncertainty. The same structure is still there, pointing in the exact same direction, but now it's stretched, brighter, and clearly split into two components. The main sunward plume is longer and sharper, the counter feature is stronger, and the whole thing has widened into a more V-shaped geometry. Here's what jumps out when you compare the two. The direction didn't change. This isn't a random artifact. The axis lines up perfectly across 2 nights. The brightness increased, a real physical source growing stronger, not image noise. The structure expanded. The plume is nearly twice as long in the December 9th frame. The symmetry improved. Both sides of the feature now show up, not just the primary plume. And here's the part that's hard to reconcile with standard comet models. Features like this aren't supposed to stay this stable. Dust fans rotate, gas jets wobble, viewing angles change. But this thing holds its line like a fixed engine. 2 nights, 2 images, same direction, stronger signal. Whatever 3I Atlas is doing, it's doing it consistently. Now let's zoom in on today's raw frames. The standard grayscale, the inverted view, and the color-enhanced map. These 3 together tell a story that the naked eye can't catch. Start with the left panel. The nucleus is a tight, focused point. No distortion, no breakup, no secondary peaks. If you only looked at this version, you'd think 3I Atlas was a perfectly ordinary comet just cruising through space. No drama. Move to the middle frame, the inverted grayscale. This is where subtle structure usually pops out. But again, the core stays ridiculously compact. No fragmentation signatures, no fan-out. Nothing that explains the weird sunward features we just saw in the rotation gradient images. And then you hit the right panel, the color-enhanced map, and everything flips. The outer halo lights up asymmetrically. The brightness distribution stretches more toward the sunward direction than the anti-solar direction, which is not how comets behave. You should see the strongest intensity opposite the sun, where dust gets pushed away. Here, it's the reverse. The region facing the sun is the one showing the excess signal. That mismatch, tight core, quiet interior, but a directional outer brightening, is a serious red flag. If 3I Atlas were shredding, the nucleus would look messy. If it were venting normally, the anti-solar tail would dominate. If the structure were just noise, it wouldn't line up across all 3 processing modes. But none of those things are happening. Instead, the core is stable, almost stubbornly stable. The halo is directional, but in the wrong direction. And the color map confirms there's real energy being pumped into that sunward region. Something is injecting momentum into that side of the coma, quietly, persistently, without disturbing the nucleus. That's not how comets behave. That's not how interstellar visitors behave either. And yet, 3I Atlas keeps doing it. Now we jump to Italy, where Tony Scarmato captured 2 new frames that line up perfectly with what Thailand recorded. And they're taken with completely different optics, filters, and processing styles. That's what makes this so interesting. On the left, you've got the raw, natural light stacked exposure. Even without any enhancement, the coma doesn't behave like a simple fuzzy blob. There's a very faint forward brightening, sitting sunward, and it's in the same direction seen in the Thailand data. No split, no asymmetric breakout, no fragmentation halo. Just a dense, stable core with a pushed forward glow. On the right, after running a Larson Sekanina rotational gradient, the structure snaps into place. The central pixel is extremely tight, around 4,000 kilometers across in this scale. But the real story is the narrow, bright extension that shoots sunward from the nucleus. It isn't bending, it isn't dispersing like dust, it's focused. The tail points the expected direction, away from the sun. But this feature? It points toward the sun, exactly like what Thailand recorded on both December 7th and December 9th. Different country, different telescope, different night, same structure. So here's where we're landing today. Multiple observers, different countries, different nights, and all of them are picking up the same forward-facing structure on 3I Atlas. A feature that shouldn't be this stable, shouldn't be this bright, and definitely shouldn't be pointing toward the sun with this kind of consistency. Something is driving this thing, and whatever it is, it's not behaving like a normal interstellar comet. Now I want to hear what you think. Is this just an unusually active nucleus? A jet we've caught at the perfect angle? Or is 3I Atlas telling us it's something else entirely? Drop your thoughts in the comments. I read every one of them. And if you want to follow this object as it changes night by night, hit like, subscribe, and share this video with someone who's been watching the 3I Atlas story unfold. We're just getting started.